Hello everybody and welcome to Chemistry Lab. Today we're going to be doing the soluble and insoluble salts lab, and we're going to start with part A, which is a investigation of the solubility of various cations and anions. And we are going to do this by using this spot plate to mix various ionic solutions together and look for the formation of a precipitate. The formation of a precipitate indicates that a insoluble ion pair is present. Now, in your report sheet, there are a number of ion pairs listed for part A. The ones we are going to be doing are the mixture of sodium nitrate with sodium chloride, the mixture of sodium nitrate with sodium sulfate, the mixture of calcium nitrate with sodium chloride, and the mixture of calcium nitrate with sodium sulfate. And we will begin by mixing sodium chloride with silver nitrate. So the first one is a bottle, dropper bottle, sodium chloride. We will place it in the upper left corner of the spot plate, like so. And we'll do 2 dropperfuls just so that we can have plenty of visual aid. So that was sodium chloride. Now we will add silver nitrate. And you can make deductions about what will happen based on the solubility of various ions. But if we take a dropperful of sodium nitrate and add it to sodium chloride, you can see what happens. It might not be you see there is a cloudy white solid that has formed. The next one is silver nitrate and sodium sulfate. So here we have sodium sulfate. I'm going to add it to the bottom left corner of the spot plate, like so. Again, we're going to put 2 dropperfuls in just to make sure we have enough volume. And then we are going to add silver nitrate to the sodium sulfate and see what happens. And again, it may be a bit difficult to see what has occurred, but the solution has become a bit cloudy. Alright, so the next combination of ions will be calcium nitrate with sodium chloride. So we will take sodium chloride and place it in the top right corner of the spot plate, like so. And then we'll add calcium nitrate to it. You can see the effect that that had. And the final combination is sodium sulfate and calcium nitrate. So I will place sodium sulfate in the bottom right corner of the spot plate. And then I will add calcium nitrate to the sodium sulfate. and you can see the effect that adding calcium nitrate had on the solution. So there are 4 results shown here. Top left corner is sodium chloride plus silver nitrate. Bottom left corner is silver nitrate plus sodium sulfate. Top right corner is calcium nitrate plus sodium chloride. And bottom right corner is calcium nitrate plus sodium sulfate. So now, as always, we dispose of our chemicals properly. We got all this nasty white gunk, so I've collected it in this beaker, and we'll pour it into our waste container. That's yummy. I have that for breakfast. I'm going to have to rinse it out a little bit with a wash bottle. Man, it's really being stubborn. But we got most of it out there, and we have our handy dandy waste container. So for part B, this procedure instructs us to weigh out approximately 3 grams of potassium nitrate. It doesn't have to be exactly 3, and in fact we'll be doing several masses, approximately 3 grams. We have 2.4 there, and 2.853, so that's approximately 3 grams. And we'll use this for our test. Alright, our second approximate 3 gram mass is being measured now. This one is 3.174 grams. And our third mass, approximately 3 grams, will be 3.09. Or 3.089. And these 3 masses will have their solubility tested according to temperature. All right. Okay, so for part B, we're going to be measuring the solubility of potassium nitrate with reference to temperature increase. We're going to start by adding our 2.856 grams of potassium nitrate to our test tube. We will do the same in another trial for the other 2 masses that we measured out. However, we're only going to show the experiment once, and we're going to give you the data for the other 2. There's our potassium nitrate, and then we are instructed to add 5 milliliters of water. I'm going to do so using something called a pipette, where it has a little crank on the side of it, where if you increase it, it acts like a syringe and pulls water into pipette. This is a 5 milliliter pipette, so we'll fill it to the 0 line. And then when we press the lever at the top, it releases the water. And then we press the plunger down to push out the rest of that little bit at the tip. We've added exactly 5 milliliters of water to this solution. Now we have to put the potassium nitrate into a hot water bath. So we'll turn the water onto some high heat and immerse the potassium nitrate into it. And we are going to wait for the potassium nitrate to dissolve completely. And the procedure says to stir with a thermometer. So we'll take our digital thermometer that we have waiting in the wings here to stir. And we'll do this from time to time as the water heats. And we'll turn the thermometer on as well. Notice we're at 15 degrees, but it's gradually increasing, and it will continue doing so throughout the course of the experiment. Notice the pile of salt is already decreasing in size. And we can see there's some heat coming off of the hot plate. You can hear the water sizzling. Got a couple chunks of potassium nitrate in here. Temperature's still fairly low. It's only 20 degrees Celsius right now. Pile keeps getting smaller and smaller, gradually. how much thinner the salt is getting. Still have one big chunk floating around in there though. That'll probably take the longest to dissolve of all of them. Bit by bit, all of the potassium nitrate is dissolving. We're now around 35 degrees Celsius. But the relevant temperature measurement will not come until we have fully dissolved all of the potassium nitrate, and then take it off of the heat and allow it to cool until potassium nitrate begins to recrystallize. The temperature at which recrystallization occurs is the relevant temperature for this experiment. We're almost there. We just got a few chunks floating around in the bottom. Gotta get these last little chunks to dissolve. Alright, so now all of the potassium nitrate has been dissolved, and we need to remove this from the heat and wait for recrystallization to occur. And we'll keep stirring with the thermometer until crystals start to form. Temperature is now dropping fairly rapidly. Something to notice, there are some floaties starting to appear in the solution. If you look really closely, there are some specks floating around in the solution. So far, it hasn't started to really recrystallize yet. We're at 45 degrees now. Push this off to the side a bit so it's not directly over the top of the hot water. Still don't have crystals. We should be getting pretty close here soon. Okay, so now we're starting to see solid form. It is 35 degrees Celsius right now. So the first solid has begun to form at 35 degrees Celsius. And as you can see, it's starting to rapidly form and crash out. And as you can see, as it cools, there's more and more potassium nitrate falling out of solution. But we'll say that the temperature at which it first began to fall out is 35 degrees. You can see the crystals that have formed. Before long, we will have all of our potassium nitrate crystallized out again, but we will not leave our thermometer in there for that because it will get stuck. So you have a mass of potassium nitrate and a recrystallization temperature. There will be another 2 such data points provided, and you will graph them and determine the solubility of potassium nitrate. Okay, so for part C, it's called testing the hardness of water, and we will be doing this by taking a sample of distilled water and placing it in a 250 milliliter flask and adding a few drops of soap to it to establish suds. This will act as our reference, and then we will do the same to 50 milliliters of seawater, and the seawater is expected to be significantly harder, meaning that it has more salts dissolved in it, and this will cause the soap to form suds less readily. We will show this by demonstration. So, for the purposes of reference, we take a 50 milliliter graduated cylinder and we pour water to the line and add it to the first flask. Now we take, it says to take 1 drop of soap solution and add it to the water. This is a concentrated soap solution. So we add, okay. And we put a stopper in, and we swirl. It says to swirl until suds form. which you can see suds have formed on the top of the water. Now, we will do the same procedure with seawater. Seawater is obviously loaded with salt of various types, mostly sodium chloride, but also potassium and magnesium. 50 milliliters of seawater. The seawater actually smells like the ocean. If you were in the lab, you'd be able to notice the smell. Add the seawater to the flask. Oh, I spilled a little bit. And take the soap solution. And it says to add 2 or 3 drops. So we've added 3 drops. And we'll swirl it. Notice that significantly less bubbles formed, even though I added more soap, and the bubbles are rapidly dissipating. Whereas the bubbles in the distilled water remain, the bubbles in the seawater are much less prominent. So that was 3 drops of soap, and the distilled water required only 1 drop to produce a significant amount of bubbles. So this is an indication of how hard your water might be. If at home, for instance, you have a lot of calcium in your water because of runoff from various mineral sources, you might taste a lot of what tastes like dirt in your water, and it might make your soap significantly less effective at sudsing, which will make it more difficult to clean things, and also possibly give you kidney stones. So that's a fun little demonstration, and you'll answer some questions about that in your lab report. Alright, now we're going to do part D of the soluble and insoluble salts lab, which is the purification of water, and we will begin this by measuring out 4 10 milliliter quantities of muddy water and adding them to these test tubes. So this is muddy water. You'll see how muddy it is here in a second. It's pretty gross. I would never drink this if I were you. Some of it's muddier than others, and we're not getting exactly 10 milliliters. But we're getting pretty close, which is good enough for this, because it's for proof of concept. Notice how muddy that water is. Now we're going to add each one to a different test tube, like so. Makes a really nice sound when you pour it. And we're going to keep these identified with their test tubes so we don't have cross-contamination. Now the procedure says to add 5 milliliters of water to the first test tube as a standard. So here we go. We'll measure out 5 milliliters of this water from the water bottle. That goes in the first one. And we'll place the additives along the back in order. The second one, it says to add a solution of sodium chloride. So we will add that here. Just to make sure we have enough. Yes. So the sodium chloride goes in the second test tube. Cap back on, put the sodium chloride next in line. The next one it says to add is aluminum sulfate. We are using instead potassium aluminum sulfate because it is chemically very similar and will work, I think, better for this experiment. So 5 milliliters of that. And that one gets added to test tube 3. And that one goes there. And then the final one, we will add sodium sulfate. And the procedure says to make sure they're mixed up, so we're just going to shake it a little bit. Look at that mud. It's yummy. Swirl this one as well. And it says to look for sediment. So you notice there is already some sediment forming on the bottoms of these. But we will come back and check these individual test tubes in 30 minutes to see how they have progressed. Alright, we're back for part D. We're checking the progress of our water purification. The first one that we did, we just added distilled water to the vial, and you can see there's a lot of sediment on the bottom. The water is still fairly brown, so we can deduce that it didn't really do anything. The second one, we added sodium chloride solution, and you can see it basically looks the same as the water, so it doesn't appear that the sodium chloride has done much in terms of making this water any better to use. The next one is the one that contains potassium aluminum sulfate. Now, this one, on the other hand, even though there's still some discoloration and some things floating around in the water, the actual mud has been reduced. And this has to do with the various solubility of the potassium aluminum sulfate and its ability to take insoluble salts and put them into solution, thus reducing the total amount of particulate matter. And then lastly, the sodium sulfate is similar. Sulfates are widely soluble, so the mud that's in this water has been reduced. However, the discoloration of the water is still present. The clearest water appears to be the one with the potassium aluminum sulfate. So that's part D. You'll be answering questions about that in your report. Now, as always, we exercise good waste management practices and we pour our muddy water into our waste container. And since there's a little bit of mud left on the bottom, spray it out with some distilled water and pour again.